Hey everyone, this is Bradley Bush with another algebra video. Today we're talking about the change of base formulas for logarithms. In our to-do list today, we have 3 items. First, we'll talk about the change of base formulas. There are 3 of them. For each of those formulas, we'll have an example, and then we'll show you how to use your calculator to evaluate them. Let's move on to the first formula. So the first formula is here in the yellow box. This is the change of base formula for the common log. So this is a formula that lets you change any log into the equivalent version as a common log. So notice the specific parts. We have any log base b. So b, by the way, is a positive real number, but it can't be equal to 1. And m is also a positive real number. So there's another m. So the formula says that we take log base b of m, which is just our original logarithm, and we can rewrite it using common logs as log m over log b. So for me, one of the great ways to remember how to do this is you notice that m is above b. It's higher vertically than b is. And notice over here, m is also vertically higher than b. So nothing changes there. You just are rewriting it with logs, common logs, instead of the original log base b. So let's look at this example here, and I think you'll find this pretty easy. So we start out with log base 5 of 2, and we can rewrite that using common logs, so log base 10. And remember, the common logs, they're base 10, but we don't write the 10, just like in the square root, we don't write the 2 in the index. So we have log base 2, because 2 is higher than 5, right? Vertically, it's above. Visually, when you look at it. So we have log base 2 divided by log base 10 of 5. And that's it. So that's really not bad, right? If we want to compute that using a calculator, we do log 2, close parentheses, divided by log of 5, close parenthesis, and we get about 0.431. We'll say 0.431. This is approximately 0.431. So that's not bad. Let's try another one. Here we go again. This is the second of the 3 change of base formulas. This one changes any log base b into the natural log, or ln. So we have the same idea happening of m is visually vertically above b, and that doesn't matter which side of the equation we're on. So m is higher on the left, so it's going to be on the top and the bottom on the right. M is lower on the left, it's going to be in the bottom, in the denominator on the right. So that is a very non-technical way to look at this, but for me it helps. So we can change log base 5 of 2 into a quantity using natural logarithms by using our formula here. It says we have the ln of m, which is 2, over, that's not a very good 2, let me rewrite that, over ln of 5, and we're done. If we wanted to put that into a calculator, we'd use our ln button here on the left-hand side in red, ln of 2, close parenthesis, divided by ln of 5, close parenthesis. And notice we get the same thing that we got when we used the natural log, and that's because we started out with the same log base 5 of 2, and we just transformed it into an equivalent form using a different log. So these both are the same, they're equivalent versions of the same log, just using different bases. So that's kind of cool. So again, this is approximately 0.431. Our last example here lets you take, again, any log base b and transform it not into a common log or into a natural log, but here we're transforming it from log base b to any other base. We'll call that base a. And we're assuming that a isn't 10 or e, or we could use one of the two previous formulas. So again, m and b are elements of the real numbers, and b can equal to 1. And I should note, because looks like I forgot it, a is also an element of the positive real, and a cannot equal to 1 because a is a base. So here we go. Let's use our formula and write this out. Log base 5 of 2. We want to write this as a log with base 3 instead of base 5. So here we go. Log base 3. And we're going to have log base 3 in the bottom as well. And we put 2 in the top and 5 in the bottom. And we're done. We've rewritten that. So there is a way to compute on some calculators. There's a way to compute this log of a base that's not 10, or the common log, or e, or the natural log. If you have a TI series, I'm using the TI 84 plus CE here, but you can go to the math field and then click down. Sorry, I'm going to click up because it's faster. And we're going to choose option A here for log base. We'll hit enter, and that lets us choose the base and then put in an entry here. So we're going to compute log base 3. We'll arrow over and we'll put 2 here. Arrow over, divided by. Now we've got to go back to the math and get that log of any base again. 3, log base 3 of 5 we're doing. And we hit enter. Notice we get the same thing. We're just changing this into an equivalent but different form. So all of these, when we evaluate them, give us the same number, 0.4306. There's one thing I want to make sure that you don't mess up on though here. So let's go back and say we're doing log, the common log. And what if I do 2 and then I do divided by 5 here? And I think, well, that did what I wanted. Does that give me the 0.431? It doesn't. I need to make sure my parentheses are closed after the 2 so that the calculator knows what is in the numerator and what is in the denominator. What if I tried log and I put 2 in now and I go divided by log of 5? Does that work? It doesn't. We need to make sure that we are closing the parenthesis after the first 2, because that will tell the calculator that we've ended what is going into the log, and it'll calculate what it should calculate, what we think it's going to calculate. So just keep an eye out for that, because it's a very common issue. So again, this was about 0.431. 1. And that's it. Here is our summary right here. I'm going to add that a cannot be equal to 1 because that's also true. We used a change of base formula for the common log. We used the change of base formula for the natural log and the change of base formula to a general log base A. That's it. Hope you enjoyed it and have fun logging.